in this video we're going to talk about temperature and what it is and how it's measured. So first, temperature tells us how warm or cold an object is relative to some standard. So for us, when we think in terms of hot and cold, we think of in terms of when we feel hot or we feel cold. But the idea is in thermodynamics, there is no such thing as cold. It's all about transfer of energy. So cold, you feel cold whenever you're losing energy, and you feel really hot or warm whenever you're gaining energy. But we'll talk about that a little bit more in heat transfer. The idea, though, is that temperature gives us a relative scale. Temperature, by definition, is the measure of the average kinetic energy of the substance. Okay, so that is your definition. You may want to emphasize that in your notes, underline it, star it, something like that. But temperature is the measure of the average kinetic energy of the substance. So when we say average, that means we take every single particle in a given substance, add all of their energies together, and divide by those number of particles. So what this is actually looking at is how much energy does each particle have. So we're not worried about the total, we're worried about how much does this one particle have, how much does that particle have. So it's by individual particles. And we measure it using a thermometer. Of course, temperature is measured with a thermometer. And the way they work, the old style ones, the alcohol ones, they have the blue and the red in them, and the old school mercury-based thermometers, the way they work is based on the kinetic molecular theory, which we'll get to in a couple of slides. But basically, whenever the thermometer is something warm, the liquid inside expands, so it stretches out. And so the reading goes up. If you put it in something cold, then the material contracts, becomes smaller, and the reading goes down. So, in terms of temperature, as far as we know, there's no upper limit on temperature. So you can go as hot as you possibly can, and there is still no upper limit on that temperature. Now, there is a lower limit on temperature, and that's what we call absolute zero. So you may want to star this too. This does not mean we're at 0 degrees. And again, 0 degrees is different depending on where you are. In the US, 0 degrees would be 0 degrees Fahrenheit. If you go to basically any other country in the world, 0 degrees would be 0 degrees Celsius. This is different. This is absolute zero. This is actually 0 Kelvin, which we'll talk about the 3 scales in a second. This is the point where no more energy, so if you want to underline that or highlight or something, no more energy can be removed. So absolute zero means that there is absolutely no more energy. You cannot pull any more energy out. Theoretically, at absolute zero, the volume and pressure of a gas would be zero because the particles inside would not be moving. So again, we'll talk about that in a second. So scales that we know, the first is Fahrenheit. That's how we measure everything. In the US, if you watch the Weather Channel, if you've got an app on your phone that tells you what the weather will be like, it gives it to you in Fahrenheit. It's used in the US, but not in science. We do not measure anything in Fahrenheit in this classroom. Instead, we'll use the Celsius scale. I'll tell you how these scales were developed in class. But nonetheless, Fahrenheit is a US-only scale. Don't use it anywhere else. Celsius is based on water. So 0 degrees Celsius is when water freezes. 100 degrees Celsius is when water boils. So this is based on water. This is why it's used everywhere else, and it is the scientific standard, is because it's based on water. Fahrenheit has a very interesting story. But freezing water is not 0 degrees Fahrenheit. It's 32 degrees Fahrenheit. Boiling water is not 0 degrees Fahrenheit, it's 212 degrees Fahrenheit. So the same object, so freezing water is 32 degrees here, 0 degrees here. This is why it's important to make sure you know what scale you are using. So Fahrenheit, US. Celsius, based on water. Kelvin was created, the scale for Kelvin was created based on absolute 0. So here, 0 Kelvin is absolute 0. That's where its scale starts. Otherwise, it's exactly the same scale as Celsius. It's just shifted 273 degrees. So here, 0 Kelvin would actually be negative 273 degrees Celsius. But we'll talk about that more in depth in class. But nonetheless, these are your scales. This is the one we're going to be using in class, the Celsius. So now, what causes temperature? Something called the kinetic molecular theory. So kinetic means moving, right? So kinetic means moving. Molecular means molecules or particles. So it's moving particles. So the idea is temperature is created by moving particles. So first, matter is made of tiny particles which are always in motion. So we have atoms, we have molecules, we have particles. They are always in motion. As they gain energy, they move faster. And we do the same thing, right? Whenever we eat our breakfast in the morning, we feel like we have more energy because we've gained energy from the food, so we're able to move better, able to run from class to class or concentrate in class and stuff like that. So gaining energy means you move faster. Faster means you have a greater average kinetic energy. So each particle, that means each particle has more kinetic energy. Here's where that kinetic comes in. Kinetic energy is energy of motion, and so here we're saying they're moving faster. That makes sense. And lastly, the more kinetic energy it has, the greater the temperature. So here we go. Quick review again. Matter is made of tiny particles. They're always in motion. If they gain energy, they move faster. If they move faster, they have more kinetic energy. More kinetic energy, greater temperature. And it goes back to what you should have starred, which was the definition of temperature. The measure of the average kinetic energy of a substance. So temperature is not a measure of total kinetic energy, okay? It's the measure of the average. So we don't care how much total energy there is. All we care about is how much energy each individual particle has. So a couple of questions to make you think. If the same amount of energy is added to a cup of water and a gallon of water, which one will end up having a higher temperature? Well, a cup of water has a very small total energy. A gallon of water has a very large total energy. If we assume that these are both at room temperature, you put a certain amount of energy in, which one will have a higher temperature? Well, which do you think? It'll be the cup. And the reason why is because that energy that's added will be distributed between fewer particles, because the cup of water has fewer particles. So each particle will gain more energy. In a gallon of water, that amount of energy has to be spread out over a ton of particles. And so each particle only gets a little teeny sliver. So it's kind of like a cake. You know, if you have an entire cake, and let's say that's the amount of energy that we're putting into the system. If you only have 2 people, so 2 particles, that means each of you gets half of a cake. Awesome. But what if you had 10 people at the party? Then that same cake has to be split up into 10 pieces. That means each person or each particle only gets a little sliver of the cake instead of a large chunk. So the next question is, can 2 containers of water contain the same amount of energy but have different temperatures? Well, of course, because again, we were talking about this idea of total versus average. So if 2 containers have the same amount of total energy, they can have different temperatures because they can have a different number of particles. So let's say you have a total of 100. If you only have 10 particles, then it's that total divided by 10. So 100 divided by 10 gives you 10. If instead you have a larger container that has 100 particles, then you have your total, which is 100, divided by 100 particles now, which gives you 1. So the smaller the container, the more energy per particle. So that's how you can have different temperatures with the same total. It's all about how much energy each individual particle has. That's where temperature comes from.